In this lesson, we are going to go through a hypothesis test, also known as a significant test for proportions. Let's begin by looking at a one-tailed test. Consider the following scenario. Does California watch more Netflix? A recent report states that 55% of U.S. adults use Netflix to stream shows and movies. An advertising company believes the proportion of California residents who use Netflix is greater than the national proportion because Netflix headquarters is located in Los Gatos, California. The company selects a random sample of 600 adults from California and finds that 360 of them use Netflix. Is there convincing evidence at the alpha equals 0.05 level that more than 55% of California residents use Netflix? So we're going to run a significance test to see if the claim is true. We're going to use the state plan do conclude model to make sure that we don't forget anything. So let's begin with state. So in my state, I've written, we want to perform a significance test using the hypothesis, and I'm going to write both my null and my alternative. So my null, using proper notation, would be h sub 0, put a colon. We're talking about proportions, so p is equal to, now I'm going to just show you some notation you're going to see is equal to p naught. Okay, so p naught is the value that you're assuming to be true. Now I don't actually write that in my notation. I'm going to put my actual proportion level, which if I zoom out, a recent report states that 55% of US adults use Netflix, but they're thinking that more do that. So for the null, that's like the no difference, the ho-hum, nothing interesting is happening here. So we're going to say that p is equal to 0.55. Now my alternative is where, you know what, that's what I have a suspicion that maybe more people in California actually watch Netflix. So now I've got to state what that parameter p actually equals. And so I state where p is the true proportion of all California residents who use Netflix, and I'm including the alpha level at which I'm going to test this. So let's zoom out here so we can see our question again. So now we are going to need to plan. What is it that we're going to do? When we plan, this is where we name our test and check our conditions. So I'm stating that if conditions are met, we will proceed with a one proportion z-test. So I've named my test, and now what are the conditions that we need to check? Well, I need to check and make sure that my sample is randomly collected. Recall that it needs to be random so that it is representative of the population. If it's a convenient sample or a voluntary sample, there's no point in carrying out a significance test for p. Well, in this scenario, we're told that the company randomly selects 600 California residents. Notice that I'm putting my descriptions in context. We need to check the 10% condition whenever we have sampling without replacement, and if you're taking 600 residents, it's not like you're putting them back in the pool to sample again. So I'm stating that 600 residents is less than 10% of all California residents, or less than 10% of the population. Okay, and then finally, we want to be able to use our normal model, so we need to check our large counts condition. So I'm showing that 600 times 0.55, which is our p naught, the value of the null that we are assuming to be true, would be equal to 330. So in my large counts, I'm stating 600 times 0.55 equals 330, and 600 times, minus p naught would be 0.45 is equal to 270. Both are greater than or equal to 10. So my conditions are met. So again, in here I've stated my conditions and I've also named my test. I just want to point out that this is also called a one sample z test for proportions. Your textbook calls it a one proportion z-test, so I'm just going to go with that. Now we're going to actually do our calculations. So some of the things you want to do in here would be to identify what's your statistic. In other words, what do we even have evidence for that's suggesting that this test is even necessary? So that's going to be my p-hat, my sample. So 360 out of 600 is equal to 0.6. So we have some evidence saying that, you know what, perhaps more residents of California are using Netflix than the rest of the country, but is that convincing evidence? So we've met our conditions and it's okay to proceed with a normal model. We've checked our large counts condition. So I'm going to find my test statistic, which is, if I'm looking at a normal model, would be my z score. So I'm going to do z is equal to, how far is this from my mean? So I'm assuming the mean of 0.55 is the true mean. So I do 0.6 minus 0.55 divided by my standard deviation. So I need to find my standard deviation, which from your formula sheet is equal to the square root of p, which is 0.55, times 1 minus p, which is 0.45, divided by my sample size, which is 600. So when I put this in my calculator, I get approximately 2.46. Okay, so from my normal model, if I am just using a normal model, standard normal here of 0 and 1, since I have my test statistic, what I'm looking for is what is the probability of getting this test statistic or more extreme. So 2.46, I'm going to have to really zoom in here on this normal model, be about this area over here to the right, which is already looking to be pretty small. Now, what notation do I need to show? I need to show I'm looking at what's the probability that my z-score is greater than or equal to 2.46. So that or more extreme. And that's going to give me my p-value. So most of you prefer to use your calculator from this point. So you're going to do normal CDF, but you must show lower being the 2.46, upper 9999, mu 0, sigma is 1. And when I type that in my calculator, I get 0.0069. So that is a small p-value. So now I'm ready to state my conclusion. And in my conclusion, I'm going to make sure that I always compare my p-value to my alpha level. So because the p-value of 0.0069 is less than the alpha level of 0.05, we reject the null. Which means that we do have convincing evidence for the alternative. And I'm going to state that in context and making sure that I'm talking about my parameter as I do that. So we have convincing evidence that P, which was the true proportion of California residents who use Netflix, is greater than, we said 0.55 in our alternative. So here's my entire test that you see in front of you. Just one thing I want to point out is, so make sure that you are also stating your standard deviation, like you're showing your calculation. I embedded mine right here in my test statistic, which is a z-score for this particular test. A question that I often get is, do you have to use the standard normal model? I would always report my z-score because you're doing a one proportion z-test. Okay, but you could do a normal model where you're using p equals 0.55 And then you would show your normal model with 0.55 for your mean, and you would use your standard deviation of whatever 0.55 times 0.45 divided by 600 was equal to. I just find it a little bit faster to draw a standard normal table because then I can just write 0, 1, 2 to the right, and -1, -2, -3 to the left. And I have a good sense immediately that something beyond 2.46 standard deviations from the mean is really going to be unusual. I just have to see how unusual to see if it's less than my alpha level that I stated in the beginning. I want to talk you through how to run a 1 proportion z-test on your graphing calculator. So it's hidden in Stat, and you're going to arrow over to the tests. Then select option 5, a 1 proportion z-test. This is the screen you'll see then. You'll see P0. So this is the value of your proportion for your null hypothesis. We set it equal to 0.55. Then you're going to enter the values for your sample. So 360 out of 600 Californians you use Netflix, excuse me. Then you're going to select your alternative. We said that our p-value was greater than the 0.55, so I selected this option. Color-wise, that's just whatever you want. And then I select Calculate. When you go to Calculate, here it shows you your z-score. All right, so if you would jump right to the calculator, you could record it from here. Your p-value and the value of p hat, which we'd calculated all these things. But if you had not listed them, this would kind of be your reminder, you know what, these are things you need to include in the do part of your hypothesis test. I also wanted to show you that if you select draw rather than calculate, it actually draws a normal curve and it will shade. I kind of sometimes just like to look at this to make sure that I did my, I entered all my values correctly, because here I can visually see it's showing me the value of that z-score or more extreme, which is what your p-value is. And then down here, it shows me what my z-score is as well as my p-value. All great stuff.